Well, you just watched me break the 7-day cylinder, and you watched me break the 14-day cylinder. Let's see if the 21-day cylinder exceeds the strength of the 7-day cylinder and the 14-day cylinder. So I'm going to use this Tinius Olsen concrete compression testing machine. Remember that this is the low range gauge, and over here is the high range gauge. On the low range gauge, the tick marks are 100 pounds apart. I don't know if you can tell that by looking at this. The tick marks are 100 pounds apart. When I go over here to the high range gauge, the tick marks are actually 500 pounds apart. So the high range gauge goes all the way up to 300 kips, so I'm assuming that this machine can go that high. The low range gauge only goes up to 60 kips. So before I test this third cylinder, I have to guess how much load it's going to take before it breaks. If I think that the load will exceed 60 kips, then I'll want to configure the machine so as to read off the high range gauge. And you remember that you can configure it that way by turning the appropriate range select valve. So right now you notice that the high range gauge valve is open, so that means that once I start the test, it's actually going to be this black needle that's moving, the black needle that's on the high range gauge. Maybe I didn't explain this in my previous video where I used this machine, but this red needle is called the dummy needle. You see I can move it by turning this knob here. So I control that with my hand. I can control this. So when I start the test, I like to have both needles starting at 0. So you see the black needle is the load needle. The black needle is the load needle. The red needle is the dummy needle. So I set the dummy needle so that it is with the load needle at 0. Once I start the test, what happens is that the load needle actually moves, and as the load needle moves, it carries the dummy needle with it. So once the test starts, I'll have the black needle moving to indicate that load is being applied to the specimen. As it's moving, it's going to carry the red needle, the dummy needle, with it. So pretend that I'm adding load. Imagine both needles moving together. Both needles moving together. Once the concrete specimen fails, the load needle, so the load needle, which you have to imagine is traveling alongside the dummy needle, once it fails, the load needle is going to drop back down. So how do I know how much load the specimen took when it broke? Well, the dummy needle freezes at whatever that load was. So for example, what is this, about 21,000? I think my cylinder will take more than that, but it's the dummy needle that tells me how much load the specimen took, because the dummy needle remains stationary at whatever load that was, whereas the load needle falls back down once the specimen does fail. So that's how you interpret this. Notice that this is an analog scale. This is analog. Do you know the difference between analog and digital? So both of these gauges on the Tinius Olsen concrete compression machine, these are both analog, as opposed to the ELE machine, which is digital. Okay, so I put the 28-day cylinder in the Tinius Olsen testing machine. So here it is, 6 inches in diameter. I've included this tilting mechanism you see down here at the base. It's got a tilting part of it that allows for, it allows for the bottom portion of the cylinder to tilt a little bit as the load is being applied. So I didn't have that bottom plate on here when I last used this machine. The top portion, the upper head tilts a little bit also, so it allows for a slightly uneven top and bottom, the way that I've configured the machine today. Righty-tighty, lefty-loosey. Okay, has it touched yet? I am going to turn the sample height adjustment wheel, which is this wheel on the top. Can you see this? You can see my hand at the top of your screen. I'm going to turn this to bring the upper head down onto the top of the specimen. So turning this, turning it, and let me see how this is lining up on the bottom. There's a bullseye under here also, and I like to get it lined up as good as I can. close enough for government work. Okay, so for today's test, I predict that the specimen is going to take more than 60 kips, so I'm going to use the high range gauge. Can you see that over here? I think you can see me. The high range gauge, that's the one over here on the right. You've seen a close-up of it before. So following my checklist, some of this stuff I did already. Okay, notice that I'm wearing goggles. Safety first. Sometimes when this cylinder breaks, it sprays a little bit of concrete shrapnel, so I don't want to get that in my eye. Okay, so turn the machine on using the lever on the right side. Now make sure that the unload wheel is closed. Okay, verify that both needles are at 0. So I'm using the high range gauge. See this? The high range gauge, that's the one on the right. And all this stuff doesn't belong on here. It looks like we're using this as a tabletop. So I'm turning this so that the dummy needle, the red needle, will be lined up with the loading needle at 0. Sometimes this doesn't want to move. Getting there eventually. Okay, both at 0. How does that look? What? And I remember that the tick marks on this high range gauge are 500 pounds apart. So I turned on the machine on the right. See that? Lever up. I verified that the high range valve is open. The high range select valve is open. Both needles are at 0. The dummy and the loading needle. Okay. Press the start button and very gently start loading it. So I'm going to turn the load wheel just a little bit. And let me film this from a different angle. Okay, so I'm going to turn this just a little bit. Can you see this? Load it just a little bit. Turn this just a little bit and let's see if the loading needle starts to rise. I'm very slowly turning the loading wheel. I see it moving a little bit here. Can of WD-40, what's that doing here? Approaching 5,000. $10,000. How does it look over here? It's starting to crack already. Let me slow this down a bit. $30,000. Slowing it down. Slowing it down. Slowing it down. $40 tips. Slowing it down. How does that look so far? What? Slowly loading. Loading. What are we up to? This thing focused? I think the lens is dusty. We're up to 50. I'm using my cell phone for this, so I think the lens is a little bit dusty. Cracking a little bit at the bottom. Whoop, what happened? See, the black needle fell a little bit. So what are we up to? A little bit more than 50,000? Let me back off. I think the focus is a little bit messed up on this. Or maybe it's just the dirty lens. Try to get a little more. $55,000. Oop, what was that? I think it's got more in it. I don't know if you can see as much from the other camera. Okay, I'm loading it a little bit faster. Approaching 60 kips. Can you imagine how heavy that is? 60 kips? I mean, that's a lot. We're over 60 kips. See some failing at the bottom there. Oh, how high did that go? I think it's blurry, you can't see that very well. How does this look? Take a look at this. What kind of failure is that? Write it down. What kind of failure is that? So a lot of the failure seems to be at the bottom. Now let's go to the other camera. Okay, we still filming over here. How does this look? Okay. Like about 62,500 pounds. Okay, let me open this. Well, I don't think it'll take anymore. I'm opening the load wheel even more. But this thing only has about a 2-inch stroke. I can't keep going and going and going until it's almost flat. Can't do it. So let me close the load wheel and open up the unload wheel and watch the bottom part go back down. So I'm opening the unload wheel. You see it dropping back down? Can you see this over here? You should see the bottom part down here. I mean, it's just off the camera. The bottom part is going back down. It's just off of the view of the camera, I meant to say. The bottom part, which is just off of the view here on the bottom, is dropping back down. Let me, if I can rotate this. Okay, so what I was trying to say was that this part drops back down when I unload it. Okay, back up again. Okay, so is it unloaded entirely? Black needle at 0, so it is unloaded entirely. So I'm going to press the stop button. Okay. So there you have it. So I'm going to shut off this camera now. Okay, so I just shut off the other camera and I moved it. So let's take a look at the specimen here. I see a big crack right here down the longitudinal axis. Anything interesting going on out over here? So let me go this way. Okay, a lot of failure back here. When I take it out of the machine, it's going to crumble, so I'm going to get the view of it before I touch it. Okay, let me go around this side. Okay, I can't look into the viewer now, so I don't know what you see. Okay, and how much load did it take? So 60,000 plus, how many tick marks above that? Looks like about 6. Sometimes the dummy needle slips a little bit, but I think it made it 6 tick marks above 60,000. So 6 tick marks, if each tick mark is 500 pounds, that's 3,000 pounds. So let's call it 63,000. It made it up to 63,000 pounds, 63 kips. It's Tuesday, November 3rd. I just broke the 3rd cylinder. It looks as though it took 63,000 pounds. I did the test at about 7:15 this morning, and so that just leaves the 4th cylinder to break, and we'll see if that cylinder takes more than the 21-day cylinder.